Okay, start.
Okay, please pay attention. Roll number 61, 62, 63, 64, 65, 67, 68, 69, 70, 14, 71, 72, 73, 74, 75, 76, 77, 78. Do we have 78? 78? He's not coming to the class. 79. Call his name. Sit down. Okay. 79. 80. 81. 82. 83. 84. 85. 86. 87. Do we have 87? He's not coming to the class. Okay. 88. 89. 90. 91. 92. 93. 94. 95. 96. 97. 98. 99. 100. 101. 102. 103. 104. 105. 106. 107. 108. 109. 110. 111. 112. 113. 114. Do we have 115? It does not exist. 116. 117. 118. 119. No. 120. Okay, let me call it again. 61. Do we have 61? No. 62. 63. 67. 67. 68. 69. 70. Anyone else missing? Sorry? 107? Hey gentlemen, quiet. Don't worry about the file, make your own file. Okay, let's get started. Last time we were working on defined menu, and we covered material properties where we defined concrete, which was 3000 psi compressive strength, and 60,000 FY, 60,000 psi yield strength for steel. Then we defined frame sections. In frame section, we defined 4 different sizes of beams and 4 different sizes of columns. You can define as many sizes as you want. Then we defined slab and wall. We defined 2 slabs, 5-inch thick and 6-inch thick, and a wall which was 9 inches thick. And I told you that for simplification, we shall define slab as a membrane. In reality, slab is a shell element. It has bending stiffness as well as axial stiffness. But when your structures are large, you need a lot of memory to solve if you define it as a shell element. So of simplification, we model it as a membrane. But if you have a single story or 2-story, maybe 3-story structure, you can go ahead and define it as a shell. And then we defined a wall 9 inches thick, and I told you that wall will always be defined as a shell element. You can never define wall as a membrane, because if you define it as a membrane, it will be practically ineffective. So after that, we defined static load cases, and they were dead loads. We defined 3 types of dead load: floor finishes, roof details, partition. And we said that out of these 3, we can have self-weight multiplier 1 for only one of them, okay, so that self-weight would be calculated and be added to the dead load. And we also defined live load with self-weight multiplier, of course, 0. And we postpone defining earthquake and wind loads because you have not studied earthquake. After that, we shall be defining load combinations. The most common load combination for buildings is 1.2 times dead load plus 1.6 times live load. So you will come here and press this button, add new combo, name it, and again I say meaningful name, 12D and 16 live. That tells us what would be inside. So all the dead loads be multiplied with 1.2, and in our list you will find the load cases which you have previously defined in the previous option. You see floor finishes, you see roof, you see partition, and you see live load, right? So I will go ahead and pick this floor finishes and make the scale factor as 1.2 and add it. Okay, then I will pick the other load, roof load, keep the multiplier 1.2, add this. Then the last one, partition, and add this. So all the dead loads I have multiplied with 1.2. Now in the same combination, remember that this is one combination, I will pick the live load, and now your multiplier will be 1.6 and add this. Now you have defined this load combination in total, that all the dead loads are multiplied with 1.2 and live load is multiplied with 1.6. okay, right now I am just skipping this one. By default it is add. You can, on your notes, you can write this load combination type and have a question mark. Load combination type, write this down on your notes and mark a question. Maybe later on you can go to the help and read about this. By default this option is fine. You can also develop envelope, ENVE, envelope. Envelope, I'm not sure if you have studied envelope or not. Enveloping means instead of plotting or getting shear force or bending moment from one combination at a particular point, the software would get the shear, bending, axial, whatever from all the combinations, okay, and plot the diagram for the maximum values out of all the combinations. But anyhow, I'm not going into the detail of this. By default it is add, and you can simply use this, but read it. So with this we have defined our load combination, which is 1.2 times dead and 1.6 times live. There is another load combination which is very first. It's not actually a combination, but it is factored load 1.4D. What happened? Oh, okay. You have your laptops. Yes. Is it something other than scale factor?
Yes.
Okay, that is related to dynamic analysis, MODE mod.
Yes, sir.
Right? Don't worry about it. Right now we are doing static analysis. When you do the dynamic analysis for moving loads, or I should say time dependent loads like earthquake and wind, then the modes come into picture. So for static load analysis you don't have to worry about mods. Okay, the other load combination which I am defining is simply 1.4 dead. In true sense it is not a load combination because there is no other load except dead. It is, you can say, factor dead load. This one is actually very first combination or very first factor load in the list of load combinations in ACI code. And maybe I think you studied this in reinforced concrete as well. So you can on your laptops you can pick all the dead loads one by one and have scale factor equals to 1.4, but this time you will not have the live load, only 3 dead loads and factor is 1.4. Please do it, everybody. When you initially try to add a new load combination and open up this message box, it actually provides you the previous values of previous load combinations. So when you will add a new load combination, so it will give you already the values of previous load combination. So what you have to do is, in previous load combination dead loads were multiplied with 1.2. So you can change every 1.2 with 1.4. Is the power back? No? Yes, I think it's back. So you already have 1.2. Change that 1.2 to 1.4 and press the modify button. There is a button which says modify. Hit that button. No live load. The very first the very first in the list of combinations is 1.4 dead, only 1.4 dead, no live. The second is 1.2 dead plus 1.6 live. You can see these load combinations in your steel book and also in your concrete book. Yeah, in the very first chapter. Okay, how can we make this thing work? Is there any light which channel is working? The light. I think the power is back. This laptop is telling me the power is back. Can you check from the back? Oh yes, it's back. Yeah, come on. Okay, by any chance you have ACI code in this laptop? Whose laptop is this? Do you have ACI code in this laptop? ACI? No? Okay. No, ACI. 318. ACI 318. Okay. Okay, I will give it to you later on. Anyhow, I have defined this 1.4D just by going here, add new combination and changing the factor to 1.4 and no live load, and of course I change the name to 14D. So that's how you define load combination, and you can define as many combinations as you want. Okay. ETABS also has default combinations in its library, and I can show you from here. Define menu right here, add default design combinations, add default design combinations. Okay, so when you hit this button or hit this option, this message box tells you or asks you what design load combination you want to add, for steel frame design, for concrete, for composite, or for concrete shear wall design. If we are designing concrete structure with shear walls, then we will check this option, concrete frame design and concrete shear wall design. It is actually composite beam design. Composite is combination of steel and concrete. Steel beam with concrete slab on top of it. That is a composite beam. Okay. So right now we are just checking concrete frame design and concrete shear wall design. Okay. So when it shall design the structure, it will pick these load combinations from its library. But sometimes what happens is that when you are looking at the analysis results, then these combinations are not available. I am not sure about the new version, so that's why I defined my load combination there, 1.4 dead and 1.2 dead plus live, 1.6 live. So we'll see in the end what happens, but that's how you pull from the library the default design combination for the design of your structure. Okay, press OK. So we did materials, frame section, slab, static load cases, load combinations, and default design combinations. We are not covering this special seismic load effect and mass source because they are related to earthquake, and right now we are not going into earthquake, and definitely you have to do it. I ask you to note it down on your notes. We'll do it later. Special seismic load effect and mass source. Okay, after this I shall go ahead and quickly sketch my members. Okay, now it will be a little different from the last time you were doing it. When you hit this draw button, draw a line, this panel, small panel appears, and from here you can pick the section. It provides you an option that right at the time of modeling your beam or column, from this drop down menu you can pick the member you want to plot, or you can pick the section you want to draw. And in this list you will see all those beams and columns which we have defined earlier. Okay, so if you have a rough idea that what could be the probable size of the beam based on the span, then you can pick it from here right now and draw it. Okay, you can modify it later on, that's not a problem. We can modify it by using the option of assign. So let's pick 9 inch by 15 inches. Okay, if my all beams are 9 inch by 15 inches, then that's the best way of doing it. You see, I hit this button, choose my option, and I make a window like this, all the grid lines in the window, and in one shot you have all the beams plotted, so you don't have to go and pick one by one. So all of them are here. Okay. Press save, and then I shall plot my slabs on one click. Now slabs are right here. We define 5 inch and 6 inches. So I pick 6 inch, sorry. So I click it like this, or I make a window and all my slabs will be in place, right? And I will go to this option and fill these objects. The slabs are now visible, so I can fill this. You know, I don't repeat things. Okay, the next thing is columns. No, actually it's very simple. You just use this I use this option, and after using this option I just pick up my slab, the right size, and just on a single click you have the slab. Okay, next thing is columns. So we have plotted the columns previously. I told you how to do it. You can do it in plan. For example, column is a line, right? So options must be here. Either you plot the column in elevation. I look at elevation number 1. I can plot these columns 1, 2, 3, 4 like this, or I can plot my columns in plan. If I want to plot in plan, I use this option, create column in region at a click, right? So I can pick my column. Say I want 15 inches by 15 inches. I pick from here, and just on a click I have all my columns. One click, one column, or I make a window like this, have all the intersections in my window, and all my columns would be in place. Okay, so that is a quick fix. And save it. So right now I have a single story structure which has all the columns 15 inches by 15 inches, all the beams 9 inch by 15 inches, and all the slabs 6 inch thick, right? These are my trial sizes. So at later stage, if you want to change your sizes, you can use the options in the assign menu. So we are now going to our next menu, which is assign menu. And when you drop this menu of assign, most of your options are dead. Okay, options will be active when you select some member. What does assign mean? Assign means that what you have defined in the library, You define live loads, dead load, load combinations, you define frame sections, beams and columns, you define slabs and wall thickness, all that. So assigning means that picking up from that library and telling the software that this particular beam or this particular column is of this size. This is assigning an attribute to our structure. Okay. If you define it in the library using the define menu, that you have 4 sections here for the beams, and if you don't assign it, then defining is not useful. Defining is immaterial. Defining is just like that you go to the library and get a book and place it in your shelf, right? And you don't read it, and one day you pick the book and return to the library. So just by getting the book from the library doesn't mean that you have actually got benefit from the book, unless you open the book or use it for some purpose. So it's the same thing. When you define it in the library, it is like the book you have received. But unless you open it, unless you use it, it is not useful. So what we are going to do now is, we are going to assign some of these sizes to our real members. And partly we have done it. When we were plotting beams, we picked that all my beams will be 9 inch by 15 inches. Now at later stage you say, okay, these beams, 4 beams or exterior beams are of bigger sizes. Maybe because exterior beams have walls, sometimes your exterior beams have periphery walls and interior beams have no walls. So maybe their size is bigger. So you pick them up, select them, and your software will tell that you have selected 16 lines. Okay. You go to assign, and this time you will see that some of the options are active. Because beam is a line element and ETABS call line element a frame. That's why the 2 options which are related to frame right here and this one are active. If you select an area, then option related to area will be active. If you select a joint, then option related to joint, the first one and the 4th one will be active. So only those options will be active for which you have selected the respective member. Okay. So I want to change the size. I have selected the member. Now I will go here, frame line, and the very first option, frame section. Okay. Hit this, and you will see the list of those sections which you have defined while using the define menu. Okay. So right now my beams are 9 inch by 15 inches and I am changing this size to 12 inches by 18 inches. Okay. And of course you can choose any size. Okay. Once you do that, you will see it will display the sizes 9, 15 for all the interior and 12, 18 for all the exterior. Okay. If I refresh this, okay, now let me tell you one option. Set building view options. I go back. Set building view options. This option right here, view by color. Right now we are viewing our model by object. What does that mean? It means that all the beams are shown in one color, all the columns are shown in another color, all the slabs are shown in another color. Okay. That's why the beams which are 12 inch by 18 inches are also yellow, as well as 9 by 15, although these two have different colors in the library. Okay, so if you pick the second option, view by colors of sections, which means that 12 by 18 section has different color and 9 by 15 has different color. So you pick this option and you will see, press OK, that your beams, I am switching off slab fill, and now you will see that your beams of 9 inch by 15 inches, it's not very clear here, but these are blue and the other ones are red. You can display your structure by color to quickly identify that whether you have used different sections or any section is different, in case you sometimes need it, because when you are designing a big structure there are so many different sizes. So just by looking at colors you can differentiate that what beam is where, so you can pick your mistake sometime. Okay, how about the columns? Okay, columns are yellow. All of them are of same section. And if you look at the slab, put the slab, object fill, this slab which is 6 inches is blue in color. If I select all these slab panels just by clicking, notice this, on my click 8 areas, 9, 10, 11, 12, 13, 14, 15 and 16 areas. If I go to assign and now I want to change the size of my slab, you will see that this option of shell/area will be active, and the first option, and instead of 6 inches now I am picking 5 inches. Okay, let me delete this unnecessary definitions. Some of them are by default and I don't need them. Okay, now I'm picking slab 5 inches. You will see that 5 inch slab has a different color. Okay, so you can change the section from the assign menu. Okay, now your structure looks something like this, and this is a line model. It doesn't show the size, 9 inch by 18 inches or 12 by 18 inches, is just a line. You can actually extrude this view from set building view options right here, extrusion. When you extrude the view, it will show you the sizes, relative sizes. Extrude. I think there is an option of extrusion in AutoCAD, right? Yes, go ahead, extrude it, and you will see something real. Right? So you see that if I look at the elevation, you see there is a depth of the member, there is width of the column, right? In extrusion, elevation 1 is at the periphery, 18 inches by 12 inches, 12 inches by 18 inches, and then on elevation 2, the interior beam is different, it's 9 by 15. Right? Okay. Okay, now look at the support. So I told you how to assign the sections to the line element and how to assign the section to the slab element or area element. Now I will tell you about joints, and for that I am going to elevation 1. Look at elevation 1, look at the supports for all the columns. Right now all the supports are hinge supports. You can see this triangle, these are hinges. Okay, in frame structure, when you have a concrete column and concrete foundation at the base, you can consider that foundation more of fixed than of hinge. So you can, I mean, it may not be a perfect fixed support, but it is more close to fixed support than to a hinge support. Why? Because you have designed foundation, right? An isolated foundation. So the reinforcement from the column enters into the foundation. So that joint, this joint, is a monolith joint. So you can consider this. Why is this? You can consider this like this: a column which has a fixed foundation. Okay? It is not an ideal fixed foundation, but it is more close to a fixed foundation than a hinge foundation. Okay? So instead of having hinges at the base, we will have fixed supports at the base. And for that we have to go to assign menu. But before you go to assign menu, you have to select your supports. Okay. Either I go from one elevation to the other and select these supports one by one like this: elevation 1, elevation 2. The smarter way is that I go to the plan of the base, right? And when I go to the plan of the base, all the supports will be visible to me. So I make a window and select all of them, and right here you will see, say, 25 points are selected, right? And you can have a 3D view, and you can see that it's not very visible, but maybe on your laptop a selected support look little different from an unselected support. There is a cross. So right now all my supports are selected. There is a cross line here which you see when the support is selected. So what you do after selecting, you go to assign and joint, restraints. You go to restraint. Okay, hit this and you will see a fixed support, a hinge support, a roller and a pin, right? So pressing these buttons will check and uncheck some of the check boxes you see in this panel. When you hit the fixed, all of them are checked. Are you studying stiffness method?
Yes.
Okay. Are you studying degrees of freedom?
Yes.
Okay. Any point in the space has 6 degrees of freedom,
Yes, sir.
right? If you restrain all the 6 degrees of freedom, it becomes a fixed support. 6 degrees of freedom have 3 translations: 1, 2 and 3, right? And 3 rotations about x-axis, y-axis and z-axis, if I talk about global axis. So if you restrict all 6 of them at any point, it means it is a fixed support. So when you hit fix, all the three translations and all the three rotations are restricted. When you hit a hinge, then what happens? Then rotation is not restricted, and you will see all the rotations will be unchecked, right? And when you hit a roller, then what? One thing is all the rotations still remain unchecked, but on the roller you allow a translation. What translation? In this case, Z or Z is vertically up. Okay, that is restricted for a roller, but this one and this one, both, I mean, on the ground the structure can move, right? Like you place something on balls, it can easily move, but it cannot go down because of vertical reactions. Okay, that's why for a roller the translation in that direction is fixed, right? It's checked. But when you hit this pin is a point in the air having no restraint, right? It's like a flying object. All the 6 degrees are free, right? So these are two extremes, fix and pin. So we will hit fix, and when I press OK, you will see that this symbol will change. Right now it is a triangle, right? It will change to something else, right? For all of them. Okay, so we have the sections assigned to our beams, columns, slabs, and our footing or foundation is also assigned as fixed. Let me see if there is anything else I need to tell you about at this stage, although there are many options. Okay, right now, not in the frame, wall, local axis, pier, tables. Okay, so right now we don't need to know much about it. We will go to loading. Okay, at this stage assigning the section is sufficient for you. There are other options which are little advanced options which we can cover later on, but now it's a time to talk about loading. Okay, what type of loading you can have? This is a structure which can have area loading, like this loading. Occupancy loading is generally area loading, and line load. What is a line load? This wall is constructed on a beam. You see that beam on the top? There is a beam underneath. So this wall is directly above that beam. So when you are modeling that beam, you have to apply the load of this wall. Okay. Now the question is, you need to know how much is the load, right? So you need to understand how to calculate UDL for a wall. Okay, and for that you need to know the dimension, right? And you need to know the density of the material. This is bricks, right? It may be around 100, sorry, in kilograms per meter cube. Yes, and in pounds it may be something like 120. Okay, I will tell you a shortcut. I mean, it's not a shortcut but pre-calculated value. So I will tell you in a minute, but let's talk about this one. So your slabs can have area loading, which can be live load, which can be dead load. It can be, I mean, any type of dead load, maybe partition load, maybe floor finishes, maybe if it is the roof, then roof details. So what you need to do is, you need to have these loads ready with you, that from the architectural plan, you need to figure out what is the loading for a specific panel. For example, you look at the architectural drawing of a school and you see that there are some classrooms. So you need to write on your plan that, okay, what is the live load for the classroom? Then there are corridors. You need to write on the drawing what are the loads for the, what is the loading for the corridor. There is a staircase, what is the loading for the stairs? And if it is a laboratory, if it is a store, any occupancy. So based on occupancy, you have to know what is the probable live load. And where do you get from? You get it, the main source, the primary source is American Society of Civil Engineers, report number 7. Okay, I want to go to notepad. Okay, ASCE, report number 7. Okay. The old version of this, ASCE 705. 05 is 2005. I think the new version is also available, but these things doesn't change much. You can download this from internet, maybe from RapidShare or somewhere. It's available. So there is a table in this report which tells you the magnitude of live loads or occupancy loads for different purposes. And I think you can also find this in your reinforced concrete book from Dr. Zaid Ahmed, right? So you can simply look at your architectural plan, look at the use of that panel, and go to that table and write down the load. So have all the live loads ready so that we can place them here. Okay, I will just for demonstration purposes, because we are doing it in pounds and feet, so I will come here and change my units to pound feet. Okay, pounds feet. Now let's have an idea. Let's have an idea in real life that what can be loading in a classroom. For example, this classroom. If I talk about 1 foot, 1 foot is a space like this. This is 1 foot maybe, and 1 foot. If you draw a box 1 foot on the ground, 1 foot by 1 foot, how many students can stand in 1 foot by 1 foot? Right? Maximum 1. Right? So imagine that we divide this room into boxes of 1 foot by 1 foot. Okay? And in every 1 foot, one student is standing. Then what would be the load, area load? What is the weight of a student? Okay, let's make it 60. Okay, 60 kgs is what in pounds? How many pounds we have in 60 kgs? That's 2.204. 60 into 2.204. 120. Around what? No, less more than 132. Right? So if in a classroom, in every 1 foot by 1 foot, one student is standing, then the load in this room on average can be 130 pounds per square feet, right? But that is not going to happen. Okay, uh, you will not see a classroom where you have one student in every 1 feet square. So based on statistical analysis and survey of many thousand classrooms, ASCE has predicted a value, uh, which is maybe half of it, around 60 pounds per square foot. For example, right now you are sitting and you are sitting on a chair, and one student may be occupying a space of no, it's more than 2 by 2 actually. It's actually on this side it may be 3 feet, and on the other side it may be 2 feet. So 3 feet by 2 feet, how many square feet? 6 square feet. So on a 6 square feet area one student is sitting. Weight of the student is say 130 pounds plus weight of the chair. Say it is another 40 pounds. So 130 plus 40 pounds, 130 plus 40 pounds, 170. So 170 pounds in a 6 feet square area. Can you quickly do the math? 170 divided by 6. What do you get? 28. Say 30. So right now, based on our sitting arrangement, in every 1 feet square, we have a load of around 30 pounds per square feet. Right? ASCE requires around 50 or 60, maybe 50, I'm not sure, I'll have to check, right? So ASCE loads are on the higher side, okay? So I strongly recommend that you just don't have to remember these numbers, you also have to have physically idea of what 30 pounds or what 40 pounds or 100 pounds per square feet means, okay? Everybody is clear about this concept? So I will, just for demonstration purposes, I will apply same load or maybe similar loads in these 8 panels. I am applying a different load. Go to assign, go to shell area loads, and yes, we are only talking about live loads. Right now I am talking about live load. Okay, go to uniform. Uniform means our load is uniformly distributed. This is an assumption. Is this load uniformly distributed? No, it's not uniformly distributed because every student weighs different and you are not sitting uniformly. Part of the slab is loaded, but this part is unloaded. The part at the back is unloaded. But we cannot mimic this non-uniformity in the structure. It's impossible. So that's why your loads are on the higher side to be conservative and because it is approximate. So hit uniform and you will have this message box. So from here you pick the load you want to assign, and in this list all those loads will be there which you have already defined in your library, right? So I am picking live load. At the beginning you can simply choose this option, add to existing load, and right here right here pick up the direction, okay, and gravity is the right direction of course, and I am putting 60. 60 means 60 pounds per square feet. Right here at the bottom you will have units, 60 pounds per square feet. 60 60 pounds per square feet says that one student is in almost 2 square feet, or in one square feet is half the student. No. Sir, 8 square feet. No. Actually, 2 square feet. One student. Yes, sir. Yes, sir. Say one student is 130 pounds, so 60 pounds per square feet. Every student is occupying a space of 2 feet by 2, 1 feet by 2 feet, or 2 feet square. Okay, this is live. Can somebody convert this in kg per meter square? Yes, sir. Please go ahead and convert this in kg per meter square. Convert this in kilogram per meter square. Yes. Slab. Okay, so 60 pounds per square feet is equal to approximately 300 kilograms per meter square. You have an idea of a meter square, right? And 300 kilogram, 293 or 300 is how many persons? 4 to 5. If it is 60, 16 to 4 is 240. 16 to 5 is 300. Right. So this means in a meter square box, approximately 5 persons. Right. So I just want to give you a physical idea of the magnitude of the loading. So I just put 60 live load at 60 pounds per square feet. Press OK, and you will see that all the panels on the top have a load of 60 pounds per square feet. And the other ones I am just purposefully doing different. Selecting again, going to assign, shell area loads and uniform. and this time I am doing 100. Okay, 100 pounds. Generally the corridors and open areas are 80 to 100 pounds. Okay, yes. Now the thing is that which option you want to pick. If you pick replace existing load, then it will replace any existing live load on these selected panels with 100 pounds. Okay. If you do add to existing load, then it will simply add this 100 to existing live load. Okay, because this is live load. And if you put delete, then of course everything is gone. So when you don't have any load already, then it's a material you pick replace or add, because there is nothing which exists. Press OK and you will have 60. Now you say okay, this was not 60, this is 80, these 4 panels. So you go select, go assign, and you say okay, you want to make this 60 as 80. Either you put 20 and pick this option, add to existing load, right? You plug 20 and say add to existing load, or you plug 80 and say replace the existing load. Either way is fine. So I do 20 and add to the existing load, and you will see this will change to 80. This is live load. Then we apply the dead load. As I told you before, we don't have to apply the self weight, it's already there. Software will calculate by itself. So I am selecting all my panels and say I apply floor finishes load. You know, this floor finishes load approximately say 50 pounds per square feet. How will you get this floor finishes load? I told you that a live load you can get from translation from the ASCE report number 7. Okay. This floor finishes load you can get from the architectural drawings. When the architect gives you the drawing, he generally shows the details of floor finishes, what materials and what are the thicknesses. So from the density and from the thickness, you can find out what is the magnitude of the floor finishes load. Okay. So by using that data, you can figure out the floor finishes, plug here and press OK, and you will see every slab panel has now 50 pounds per square feet. And on the top, right on the top, I mean in this window on the title, you see uniform load gravity floor finishes, FF. You see FF? But you don't see live load, right? You don't see the live load which we have already defined or already assigned. So it is actually there, but it is not visible. Okay, I can show you how you can look at it, but before that I want to apply the partition load as well. Okay, now there can be two types of partitions. One partition load, for example, this partition wall, which is partitioning S7 from S6, this is directly constructed over the beam. There is a beam underneath. So this type of load, this type of partition load can be directly applied on the beam as a UDL, as a line load. Okay, distributed line load. But there may be partitions which are inside the slabs, or on the slab panel, not on the beams directly. For example, right here, this is one beam and that is another beam. In between, there is no beam. There is only slab. So if you construct some wall here maybe make a small cabin, or sometime in the halls there are low height partitions, or you may small cabins sometimes. So those partition walls apply the load directly on the slab. So you have to calculate those partition loads and distribute it over the slab. And how can you do that? You can simply get the calculate the self weight of all the walls. How? From the wall thickness, from the height, and from the length. You get the volume, multiply with the density, you get the load, and divide it with the area of the slab. So what you will get? You will get a distributed partition load. But this is only for the walls which are directly constructed on the slabs, not for the walls which are constructed over the beam. Yes. Now that is your judgment. If you see plenty of walls in the room all over, okay, then it is better that you distribute over the entire area. But if you see that right in the corner somewhere you have some construction, then it is not logical that you get the load and divide it over the entire area. It's not logical. So in that case you can distribute the load over the smaller area. That's why I have modeled my structure in individual panels, so that if there is specifically a load on a particular panel, I just assign the load to that panel and not to the entire floor. Okay. So I want to select all of them again. I selected all of them previously. So instead of clicking all of them again, I can just go here and hit this button, get previous selection. Okay. When I hit this, you will see all my 16 areas will be selected again. And I go to assign shell area loads, and this time I pick partition load. Okay, and I am assigning a partition load of 70 pounds per square feet. Now partition load is also something which is different for different panels, right? In some panels there is partition load, there is partitioning. In other panels there may be no partitioning load, right? And for example, at the roof on the top, you don't have any partition load, you only have roof details. So 70 pounds per square feet, and I press OK, and all my panels are now 70 pounds per square feet. Okay. Because there was no partition load existing already, so it doesn't matter. I choose add or replace. Okay. Add or replace will only work with partition load. I was applying 70 pound per square feet partition load for the very first time. There is no existing partition load. That's why you pick the add option or replace option. It's immaterial because already there is 0. So no. It's because you have defined them in different separately. There is an option you can actually define only one dead load. I have defined 3 dead loads: partition, floor finishes, roofs separately. If you choose to define only one dead load, then you have to manually add them before applying it. That you calculate the partition load, you calculate the floor finishes, sum them up on the paper, and you apply the sum here. But it is advisable that you keep them separate, because sometimes you have to make some specific change. So if they are combined, then changing becomes lengthier procedure. So I strongly say keep them separate, although all of them are dead loads. Okay. So I have applied live load, floor finishes and partition. And let me show you the way how you can make one of the the loads visible to you. Right now you can see partition loads. So if you go to display and say show loads and come here, shell area, because these are area loads. You can also use the option of frame loads to display the line loads. Okay. Right now we have not applied any line load on the beam, it's only the area load. Okay. So you hit this shell/area loads and you will be asked what load you want to see, and in the list you will have the loads which you have defined. Okay. Floor finishes, roof, partition and line. If I pick roof, have I applied any roof load? No. So if you pick any load which you have not applied, you will see that this OK button becomes inactive. That tells you that you have not applied this load. Sometimes this option is also helpful when you want to pick whether you have applied certain type of load or not. You go here and it will tell you that no, you have not applied the roof load. So you go back and apply the roof load. Yes, I want to see live load, and now you will see live load is active. No, you can only display one load at a time. Press OK and you will see your live load will be visible. 100, 80, 60. Okay. Next option is, yes, there is another way you can see all the three loads, not on the panel, but you can get that information. Right click on your slab panel. When you right click on your slab panel, you have area information. It tells you what area is this. For example, this is 225 feet square area on which you have clicked. One panel is 15 feet by 15 feet, so that tells you area, it tells you perimeter, it tells you other coordinates. It tells you assignment. It tells you that you have assigned a 5-inch slab to this panel. Okay. It tells you what loads you have applied. You have applied floor finishes of 50, partition of 70 and live load of 80. Right. So you can see that information together at one point on a right click. You can also see its label. The label is F7. Okay. It's on story 1. Okay, so we finished applying area load. Now we can talk about line load. Line load is a uniformly distributed linear load, and it generally comes from the walls. Look at this wall. This wall is a line load. This wall is a line load. It has no third dimension. It has a linear distribution. When you are calculating the line loads from the drawings, you ignore the openings of doors, windows and ventilators. Okay? You don't have to be that precise, and you don't know, maybe in future they just construct the wall instead of window. You don't know about the lifespan. So whenever there is a wall, consider it as a solid wall. Okay? And you determine line load. If I give you the dimensions, but don't worry, I will tell you. If you have, I have not calculated by myself, but I have learned. If you have a 9-inch wall, a 9-inch thick wall, this wall is 9 inch thick. If you have a 9-inch thick wall, which is 1 foot high. A 9-inch thick wall, which is only 1 foot high, its weight will be 90 pounds per foot. You can do the math later on, and I strongly recommend that you verify this number. Okay, 9-inch thick, 1 foot high, and length is immaterial because I am talking about 1 foot. Okay, 9-inch by 1 foot. I mean, this is 9-inch wall. Up to this point, 1 foot. The load is 90 pounds per foot. If it is a 12 foot high wall, then what you do? Simply 90 into 12. Okay? And this is a linear number. Means a 4.5-inch thick wall, which is 1 foot high, is 45 pounds per foot. Half of it. If it is 13.5-inch wall, then 90 into 1.5, right? So 9-inch wall, 12 feet high, omega is 90 into 12. What is that? 1080 pounds per foot, right? But verify this number. I mean, you should know how to do it because you may have to do it in future. Nowadays, people also use blocks instead of masonry. I mean, instead of this clay brick, people are also using concrete blocks, which are generally 8-inch thick. Okay. Now, for an 8-inch thick concrete block, which is made up of concrete, the thickness is different. The density is also different. So this 90 pounds per foot will not work there. You have to calculate it by yourself. So that's why I'm saying that you should get this number by yourself. Okay? So anywhere you have a partition wall directly on the beam, you shall apply this UDL. Okay? So let's assume that in our structure, walls are only at the periphery. Okay. So what I will do, I will pick up all the peripheral beams I want to quickly pick up the beams. I switch off floors, I switch off columns and see what I get. I simply get the beams. Just a minute. Okay. So you see that when I selected beams, my joints are also selected. But don't worry about the joints because when you select a beam and then joints are also selected, the load will only be applied on the beams if I use this option of frame/line load. When I use this option of joint/point load, only then the load can be applied on the joint. So no matter it is selected or not, if I am using this option of line load, only my beams will be getting the loads. So first you select the beams, then you go to assign, then you go to the frame/line load, and then you tell or pick whether you want to apply a point load on a beam anywhere or you want a distributed load. We want a distributed load of 1080 pounds per square foot or per foot. Okay. This panel opens up. Make sure that units are pounds and feet. and make sure that your load is appropriate load, the type. It's not a roof load, it's not floor finishes, it is partition. It's not a live load. Okay, it's a partition load, which is a dead load. Then it's a force. It's not a movement. Okay, it is a force. You can apply point movement if you want. I mean, just telling you, it's a force. The direction of this force is gravity. Okay. Now there are two options here. One is trapezoidal loads and the other one is uniform load. This option of trapezoidal loads is used if you want to apply a VDL. Okay, you want to apply a VDL, you use this option. But in our case, and in most of the cases you have a uniformly distributed load, then you will use this option. And our load is 1080. So I come here and say 1080. Okay? Everybody is clear about this? This is very, very important. Sure. We are assigning. Yes.
We have not option of partition load. How can we
Okay, a very good question. For that you have actually to go to define again and to static load cases, and from here pick dead load and name the load partition load and then add new load. Okay. Okay, so I have selected all my beams where I want to apply partition load. I go to assign, go to frame line load and go to distributed load. Do you remember I told you that if you have that small symbol right there, what does that mean?
We can find it anywhere on the window.
Not anywhere on the window. Right here. Right here in our this bar. No, it's not called menu bar. This is menu bar. This is toolbar. Right here, toolbar. Floor finishes, on-fit, force, gravity, and load is 1080. 1080. Yes, we have to make sure it is PL, not FF. It is partition load, okay? And you will see a distributed load. Okay? And I will switch on my columns and beams because of floor. Okay, now again it disappears, but you can use the option of display. Show loads, frame line loads. You see, when you pick FF, this option is dead because you never applied a line load which is FF. You have no live load which is line load, so that's dead. You have only partition load which is a line load, that's why it is active. And you see the load, right? You can change the units and it automatically changes. 1.08, right? This 1080 pound per foot is actually 1.08 kip per foot, right? Yes. Sorry? Okay. The question is that, please pay attention. The question is that the same load is also visible on her columns. That's because when you selected the beams, you also selected the columns. When I selected the beams by making the window, I first switched off my columns. Okay? So if you select the columns by mistake and you assign the line load, it will be also visible on the columns, you see. So make sure that you have appropriate selection. I selected by window, but before that I switched off the column, but she didn't switch off the column and make the window. So all the columns were also selected, right? That's the problem. Undo this. Okay. Yeah, we stop here. But you have to give me your groups. Okay, who are the group leaders? Group leaders can raise your hands. Very good.